Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to learn algebra. Today is our lesson number 83. Day number 83. We're in the process of learning how to divide algebraic expressions. Day number 83. Let's see what we have for today. Here's the problem. 63 p raised to 10 q raised to 7 r raised to 5 minus 27 p raised to 6 q raised to third r squared by 9 p raised to 7 q raised to 4 r squared. We are asked to divide this expression right here. We are asked to divide it by this guy right here. So let's do it. So as we already know, we need to distribute this term across this expression. So we have 63 p to the 10 q to the 7th r to the 5th over this guy 9 p to the 7th q to the 4th and r squared minus, this minus comes down, 27 p to the 6th q to the 3rd r squared over this guy 9 p to the 7th q to the 4th r squared. That's how the whole thing looks like, and we just have to take care of it. Take your time, it's not difficult, it just requires a little bit of concentration to make sure you don't muck it up, because it only takes one letter and one exponent. If you're off by one exponent, instead of 3 you put down 4, you're done, that's it, the whole answer is wrong. There are no partial credits here, do you understand? So let's get going. 63 divided by 9, well, how many 9s in 63? 7, I believe, because 7 9s are 63. Because I know that 7 10s are 70. Because if you have 7 10s, that's 70. If you take away 1 7, that's 63. So 9 7s are 63. P to the 10th divided by p to the 7th, p to the 10th divided by p to the 7th is same as p raised to 10 minus 7, which is p raised to the 3rd. That's what we're going to show here now, except we're not going to show it in a childish way. This is how we're going to show it. Take out this guy, p to the 7th disappears, and this 10 power becomes 3rd. You see, it becomes 3rd. P to the 10th divided by p to the 7th became pq. Let's do this guy. Let's do the q now. Let's do the q. We have q to the 7th over q to the 4th, which is same as q to the 7 minus 4, which is q to the 3rd. We're going to do the same thing again. We're going to show that q to the 7th becomes q to the 3rd when it's divided by q to the 4th. So here is the q to the 4th disappears, and this 7 turns into a 3. Let's go on to the r. R to the 5th over r to the 2nd is same as r raised to 5 minus 2, which is r raised to the 3rd. R raised to the 3rd, which is exactly what we're going to show here. We're going to show the fact that if you were to divide r to the 5th by r squared, this r squared disappears, and this 5 becomes a 2, right? 5 becomes a 3 rather, right there. R squared disappears, and this 5 is going to become 3, the exponent. That's it. It looks quite messy, but you got to keep track of your work, which is why it's very important that you line up things properly in a neat, nice way. Don't make it messy. P's have to line up, Q's have to line up, everything has to line up, the coefficient have to line up. You understand? Keep it clean, keep it neat. It's easier to keep track of things. 27 divided by 9 is just 3. Now, this is where the things are going to get prickly. Okay, pay attention. On the top we have p to the 6th. On the top we have p to the 6th. On the bottom we have p to the 7th. On the bottom we have bigger exponent than on the top. So how do we handle it? Well, there are two ways you can handle it. One is to show it like this. This is the same as p raised to 6 minus 7. Well, 6 minus 7 is negative 1. You could leave it like this actually. It's perfectly fine. Or you can show the fact, we can show the fact that if you have p to the 6, which is same as p times p times p times p times p times p over p multiplied by itself 7 times, p times p times p times p times p times p times p. Well, what we're going to see is that these 6 p's there, this is going to go with that one, 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 this is going to cancel out with this one, this is going to go with that one, and what we are left with is 1 over p. 1 over p, p to the negative first power is same as 1 over p. That is correct. For example, let's erase all of this thing here. For example, do you know how to write a half in a fancy way? Do you know how to write a half in a fancy way? The way a mathematician might write a half. A half is like this. 2 raised to negative 1. Why? Because 2 raised to negative 1, as you just saw here, p raised to negative 1, p raised to negative 1 is same as 1 over p. You saw it right here. Therefore, 2 raised to negative 1 is same as 1 over 2. Voila! Do you know how to write a third in a fancy way? Of course we do. A third can be written like this. Third, 3 raised to negative 1. So 3 raised to negative 1 is same as 1 over 3. Do you know how to write a fifth in a fancy way? As you can see, the plot is thickening, isn't it? I know. Where do we write 5? Right here. 5 raised to negative 1. 5 raised to negative 1 is same as 1 over 5. And I bet you don't know how to write tenth in a fancy way. You do you? A tenth in a fancy way would be 10 raised to negative 1. 1 over 10. Voila! You get the idea. So, a number raised to a negative 1 simply means we're taking the reciprocal of it, 1 over that thing. That's what that is. So the p is going to stay at the bottom. So here we have to show something different. This p to the 6 is going to disappear from the top, and this 7 is going to become 1. That's it. It's just p, which means it's p raised to the first power. Same exact thing is going to happen to the bottom one. q to the third power divided by q to the fourth power means the q to the third power is going to disappear, and q to the fourth is going to just become q to the first power. Here we see r squared and r squared. R squared and r squared are going to take each other out. So what we're left with at the end, pay very close attention, what we're left with at the end, as I said before, you have to keep an eye on your inventory. What we're left at the end is 3 on the top, nothing else on the top, 3 on the top, and p times q on the bottom. That's our answer. So let's write down the answer. I need the room, so I need to get rid of a lot of things. Only thing I'm going to leave here is this fact here, so that you understand that any number raised to the first power is same as 1 over that power, or 1 over that number. I'm going to say it one more time. Any number raised to the first power is same as saying the reciprocal of that number. Now, how do you write any number in the language of algebra? When mathematicians are talking about any number, they prefer, the tradition is that, the custom is that, the convention is that one represents any number with the letter n. Get it? Number, n, they start with n. I know what you're thinking. Mathematicians can be quite creative sometimes. There you go. n to the negative first power is same as 1 over n. It's mind-boggling how creative they can become. So what are we left with here? We're not left with 3, 3 and 3. These are the exponents. P to the third, Q to the third, R to the third. So we have 7, P to the third, Q to the third, and R to the third. And here we have 3 on the top and P times Q on the bottom. P times Q on the bottom. This is our answer. Voila. That's it. That was the end for today. I will see you tomorrow on day number 84. Alright? See you tomorrow then.